So we are going to take a little step into some coordinate proofs here. I want to break these down as simple as possible. To do a coordinate proof, we are going to find distances and slopes. Okay, and then it says instead of writing statements and reasons, we're going to do this instead of writing statements and reasons. More than likely, we haven't done any proofs yet. All right, because we've changed the order that we did this around in the recent years, and so we no longer do proofs before coordinate proofs. So you don't even know what a proof is yet, more than likely. All right. So what we're going to do is we're going to take a shape. We're going to have, we might have 3 sides or 4 sides. It's going to be basically a triangle or a quadrilateral. And we're going to have to prove that it is something or that it's not something. And to do either of those things, I need to know the slope and the distance of every side. All right. There are sometimes a shorter way to do it, but you better make sure that you're right. Okay. Because if we're doing one of these problems and we want to make sure that we have the easiest possible time getting the maximum number of credit, the maximum number of credit, maximum amount of credit, when we're doing one of these, if I have all the slopes and all the distances, I have everything I need no matter what. Okay, now maybe my statement's not perfect, but I have everything that's there. So it should help me out when I deal with this stuff. Okay, so we're going to find the slope. We're going to find the distance of each side. We're going to organize it nice and neat so someone can look at it. All right, to be able to do this, there are 3 kinds of triangles. This file is going to have to do with triangles. The next couple of files have to do with quadrilaterals. All right, it's more than likely there's going to be a mixture of this when you get a question on a test. Isosceles triangle, 2 equal sides. I know it has equal angles, but we're not going to mess with angles on the graph. Okay, equilateral triangle, 3 equal sides. Again, I know that it has equal angles. We're not messing with that. Scalene triangle, I'm going to show that all the sides are different. All right, so real simple. So again, for there, I don't really need the slope, but I'm going to try to get you to find them anyways. It doesn't take that long. Right triangle must have 2 sides that are perpendicular because it has to have a right angle. Okay, that comes from slopes. So again, there's a little flexibility here depending on how much you want to think. Least amount of thinking, find every slope, find every distance, put them in a nice little neat organized thing, then say what's happening. All right, and that's what this should say right here. Find the distance and slope for each side in a neat and orderly manner that's labeled and easy to read. Okay, and then we're going to write a statement, 1 sentence usually. Doesn't even need to be a sentence. I don't care if it's a complete sentence. All right, stating what type of figure it is and which property shows it's that shape. I start every one of mine with based on my calculations for 3 reasons. Number 1, it reminds me that I better have done some calculations. Okay, if I'm saying a statement and I have no calculations, it doesn't make a lot of sense. Number 2, it tells the person grading it, I did some calculations, go look at them. All right, because that way I don't have to write as much stuff in there because I can just talk about how maybe the slopes are the same, they're parallel because they're the same, and you can go look at them. Okay, number 3, makes me sound like I know what I'm talking about. Okay, and I'm going to be real honest with that. That's helpful. All right, when someone reads something and thinks, this person knows what they're talking about, that gives you immediate credit when you're doing something. So do you have to start there with based on my calculations? You do not. Would I suggest it? 100% yes. Okay. Try several of these, okay, to get used to the process. This is something that you have never done before. All right. We maybe found 1 slope or 1 distance, maybe 2 distances and compared them. We have never found 3 slopes and 3 distances or 4 slopes and 4 distances in a problem. We've never done that before. Okay. So we want to make sure that we think about this and get the most possible learning done. And when we actually have to perform one of these, the most possible credit.